Good morning, everybody. Thanks for joining me again for another Sprinkler Talk. This is Sprinkler Talk number 14. Last week, number 13, we looked at commissioning, all the different things that are required for commissioning of a sprinkler system. And as I say, I was looking at it from the point of view of being the building owner or the building manager, the end user, the consultant. So basically, you're sort of asking the sprinkler contractor to demonstrate the system to you, and so that kind of you're satisfied that you've got a fully working sprinkler system. Kind of what questions you need to ask, what checks do you need to do, what information should the sprinkler contractor be giving you in terms of the handover and the certificates and things like that. So have a listen to that. That'll be on YouTube quite shortly. That'll be available to watch again. But as I say, today's presentation is number 14, and we're going to be looking at the basics of sprinkler head layout. I thought I'd be able to cover this all in kind of one section, but I think I'm going to do, again, several parts to this. So today we'll look at some of the general principles of what we're trying to accomplish, and then I'll give you an example from a kind of a warehouse. So it'll be more of an industrial building that we're looking at, so kind of a large open space. How do you lay out sprinkler heads in that kind of area? And then I think it'd be useful for me to do another session on this, and I'll show you how to lay them out in a more of a residential setting. Basically, you've got the rooms are going to be much smaller. So in the example, we've got 20 to 30 heads laid out in one room. For residential, it's going to be 2, 3, 4, 5 heads. Typically, if you've got more than 5 heads, then it's a pretty large room that you've got there. So as I said, I think it'll be useful to revisit that, because I know that a lot of you guys watching are more into residential than industrial or commercial. Okay, so let's make a start then. So this is the first thing here. What are we trying to achieve? When I say head layout, I'm talking about the placement of the sprinkler heads within the ceiling. I'm not going to be talking about void protection today, or kind of the other more nuanced things. We're just talking about, say, sprinkler heads in ceilings. So what are we trying to achieve? Well, obviously we want them laid out in line with code standards. So code standards will give some do's and don'ts, and obviously we need to take heed of that, because we want to have a sprinkler system at the end of the day which we can sign off and say, yes, this sprinkler system is installed in accordance with this code standard. So obviously we want to do that. Minimum design density requirements met. So design density is to do with the amount of water that is discharged per minute over a given area, i.e. 1 meter squared. So it's obviously design density is affected by various things. The number of sprinkler heads that you've got in the room, obviously the more heads discharging water, the more water in total is going to be discharged. Also, the K factor of the sprinkler head, the pressure behind the sprinkler head is all going to have an influence in terms of how much water is actually expelled in the event of a fire. Design density is also kind of talking about spreading the water out, which is my next point. We want to meet that design density, minimum design density, on all parts of the room or the space in which we're protecting. So as I said, it's a minimum design density, and we'll tell you. I'll give you some figures in the next few slides. Water reaching all parts of the room or area. Makes sense. We don't want a fire in one side of the room where there aren't any sprinklers and all the sprinkler heads on the other side. So yeah, that's pretty obvious. And then say that that's linked to, again, the next point, water evenly distributed as much as possible. So what we're looking to achieve is close to the minimum design density, because we want to avoid having many sort of additional water discharge than we need, because we're wasting water, we're adding. We're not doing any good really by adding more and more water. So we want to stick as close as we can to the minimum design density. We want it distributed evenly throughout the room as much as we can. But that's basically impossible to do, because the sprinkler head will give you a sort of a circular discharge pattern. Rooms are generally square, so there's always going to be variation in design density throughout the room you're in. But that's kind of what we ideally we'd like to achieve. Avoiding other surfaces and obstructions. So again, I suppose that's depending on what kind of world you're in. If you're a sprinkler guy, then obviously the sprinklers are the most important thing and usually go in first, and all other services can kind of work around you. But not everyone sees it that way. They might say, okay, no, we're going to have the lighting in first, and then the sprinklers you can kind of work around the services. But obviously that has improved a lot, particularly with the introduction of BIM. And this idea of coordination through consultants and kind of a centralised third party which is looking after all of these services and making sure there aren't any clashes. So that's kind of got a lot better. But yet sprinklers, we're taking up some space within the kind of the service area, and we need to be aware of other services. And obstructions, so I'm talking beams, columns, supports, areas of sort of structural parts of the building which we're not allowed to drill through. Could be other ducts, for example, that are in the way. We need to kind of work around them. Heads laid out in a manner to aid easy pipe distribution design. So that's kind of a minor thing really, but we do need to be conscious of where the distribution pipe is coming from, and that can affect the design. And also efficient hydraulic design. Those last 2 points are really to do with the laying out of the pipe rather than the heads themselves, but again, it's all tied in together. Obviously, if you are a sprinkler designer, then that is your job, and you'll be laying out the heads and the pipe. So the two kind of go hand in hand, really. Okay, so we talked about discharge densities in the last slide. So here they are then in kind of black and white. So BSEN 12845, that's the industrial and commercial sprinkler standard. For light hazard, we want 2.25 millimeters per minute. So then, like I said, it is to do with liters per minute over a given area. If you do some maths on that, you can kind of boil it down to millimeters per minute, and that's kind of the unit that we use. Ordinary hazard is 5 millimeters per minute. HHP is high hazard process, 7.5 to 12.5, depending on other factors. And high hazard storage, 7.5 to a whopping 30 millimeters per minute, again, depending on what we're storing and how we're storing it. So those are kind of fluid figures there. I mean, in my head, light hazard doesn't really exist anymore. It's very, very rare to have a light hazard application. And the world that I'm in is really down to zone checks. Zone checks are there primarily for buildings with life safety. Life safety is ordinary hazard because you can't have life safety and high hazard, because they're just not really compatible, are they? Why would you have sort of large numbers of kind of members of the public in a high hazard environment? It's going to be sort of a specialist kind of area for that. So vast majority of the time we're looking at 5 millimeters per minute. 9251, so just bear in mind this is the 2014 edition, that is the current version. but the a revised version of 9251 is due out, I believe, this year. It's going to be released. So we have 3 categories: category 1, 2, and 3. Category 1 basically is a standard family house, and then category 2 and 3 we're talking care homes and residential units, that sort of thing. So again, category 1 2.04 millimeters per minute, category 2 and 3 2.8, and then 16925, so the new kind of European standard. Again, we got our 3 categories, and we have 2.1, 2.8, 2.8. Just a note there, because it's a European standard, so it does actually have some figures in the official sort of table in the main part of the document, and those figures are different to what I've got listed here. That is because I've taken these figures from the UK National Annex. So again, depending on where you are in Europe, your figures will be different to ours in the UK. I suppose it's down to experience, down to research. Why? I mean, I think ours are higher. I think our discharge densities are higher than what it says in the main standard. So yeah, we're just looking for more millimeters per minute to be discharged, because I guess we feel more comfortable there. We feel that is offers better protection than the figures in the other table. So yeah, that's pretty straightforward, really. It's no surprise that the 12845 figures are higher than the residential standards. A larger fire, category A fire, needs more water discharged onto it to have the same effect. This is more like just a side note, really. I don't want to get too kind of sidetracked by this slide here, but this is just showing you 2 ways in which you can lay out sprinkler heads. The one on the left is what's called a standard layout, and the one on the right is a staggered layout. And it's really just out of interest that there are obviously lots of different ways which you can lay out the sprinkler heads in lots of different ways, and obviously depending on the shape of the room, you'll have a lot more options for how to do it. And the staggered layout, you can see we actually save a sprinkler head. Generally speaking, we don't do staggered. We do the standard because, as I've said before, I think on this platform, sprinkler heads are very cheap. Pipe work is cheap. You're already there on site. You've already got the access equipment. You're already kind of paying for all the labour. An extra head, an extra bit of pipe is negligible, really. So generally, we like to lay out our sprinkler heads in nice, neat rows. Because it looks nice, but it reduces the number of bends and sort of complexities, and it's just easier, simpler to work with, really. So yeah, say that the staggered layout on the right, is just kind of for interest. The one on the left is typically how we do things, and I just want to highlight to you the S and the D. I'm not sure why we call them S and D. You can think of it in terms of X and Y, because that's a more common way of doing it. But basically, we've got an X distance, so a kind of right to left distance, and we've got a north. So yeah, let's call it that. Let's call it east and west distance and a north and south distance. And together that forms the design spacing of the sprinkler head. I just want you to remember those figures there, S and D, and you can see we've got half S and half D to the walls, which is ideal, really, to keep things nice and neat as we go forward. So as I go through the example, just kind of remember what S and D stand for. Spacing then under 12845, we have a few. As I say, the rules give us some basic do's and don'ts, and this isn't all of them by any means. There's lots of other rules in the standard there about what happens when you've got beams and bays, what happens when you've got obstructions, how far away do you need to be from ducts and things like that. So there are lots of rules, but these are the kind of the basic ones here. And again, mainly we're looking at the ordinary hazard part of this table here. We have the maximum area per sprinkler. So that is the maximum area that one sprinkler head can protect. So you see light hazard 21, ordinary hazard 12, high hazard 9. Again, that makes sense that the higher the hazard category, that the more sprinkler heads we're going to have within the same area, because the spacing is less. The maximum distance between sprinkler heads, 4.6, 4 or 3.7. The maximum distance from the wall is half the maximum distance, or half the design spacing. Okay, so for ordinary hazard, 2 meters is the absolute maximum you can distance from the wall, but say generally speaking, that is determined by half the design spacing rather than having 2 meters at the end. So that's partly down to keeping things neat and tidy, but it's also say down to the distribution of the water as well. And then we have the minimum distance between sprinkler heads. So this can be a little bit tricky to kind of get your head around what that means. So that means that sprinklers should not be closer than 2 meters. Okay, I'll say that again. Sprinklers should not be closer than 2 meters. Okay, so 2 meters apart is fine. 1.9 meters, no. And that is to do with the discharge sort of interfering with other sprinklers close by. I think there is more to it than this, but the easiest way to think about it is that if you've got a sprinkler head which discharges water onto another sprinkler head, that's going to cool that bulb down. So that bulb will then not operate when it should operate, because it's basically being water cooled by the sprinkler next to it. Okay, so that's what we want to avoid. But so there is but more to it than that in terms of skipping, etc. But yeah, that's the general idea. We don't want the heads too close together, and we don't want them too far apart either. So we can get a kind of a dead spot in the middle. We want water to be distributed everywhere. Design spacing rules under 9251. So maximum area per sprinkler is 25, or in accordance with the approval listing, whichever is lesser in that case. Maximum distance between sprinkler heads 5.5. Maximum distance from the wall, same again, half the maximum distance or half the design spacing. Minimum distance between sprinkler heads 2.4 meters. 16925 is an example of the way things are going, really. You'll find that the MIST standards are very much like this as well, where there is very little sort of black and white information in the standard. It'll just say, basically refer to the approval listing. The manufacturer will guide you in terms of what those figures are, and that is in accordance with the approval of that particular sprinkler head. So, for example, the maximum area per sprinkler not specified. So basically saying, look, whatever the approval says is the biggest area you can protect, then that's what you go with. As I say, that just seems to be how standards are going. Moving towards this idea of being more individual to the approval rather than a sort of a set figure which applies to everybody. Okay, let's go through an example now then. So this is a warehouse. It's a storage warehouse, let's say for kind of footwear or something. And we've got a storage category 2 here, storage methods ST5. I'm not going to go into that today, but the key thing is it's OH3 protection. So it's OH3 protection, so the design density is 5. The maximum area of operation is 260 meters squared. Again, we don't have to worry too much about that. The maximum area per sprinkler is therefore 12, and the maximum spacing is 4. Okay, so based on the tables that I showed you earlier, and you can see we've got 19.5 meters going kind of east to west, and we've got 15 meters going north to south. So the first thing that we do is we basically decide, which way are our range pipes going to go? Are they going to go east to west, north to south? Now that will be affected by, is there a slope in the ceiling? Is it like a pitched roof? Which way are the kind of support beams going? That's going to have an influence. Most of the time, you want to go with the supports and the beams and the slope of the ceiling. But if it doesn't make any difference, then actually you could calculate it both ways round. You could see maybe you can save some sprinkler heads by going east to west or north to south. So you can kind of work it out both ways, and then you can see which one gives you the most favourable answer. But say in this example here, we're going to go from north to south. So as I say, the maximum distance between sprinkler heads or range pipes, because the heads are going to be on the range pipes, is 4 meters. So we've got 19.5 meters going from side to side. So we divide that by 4, okay, because 4 is the maximum spacing. And we get the answer 4.875. Okay, so we need to round that up to the nearest whole number. So we get 5. So at this point, we're saying, right, there's going to be 5 ranges going from east to west here. So now we need to calculate the D value. So remember that diagram I showed you earlier, showing the S and the D. So D, say you can substitute that for X if you like, going along the bottom. So what is that D value going to be? Well, we've got 19.5 meters and we've got 5 range pipes. So we do 19.5 divided by 5 and we get 3.9. So D is equal to 3.9. And therefore, the distance to the walls is going to be half D, which is 1.95. So you can see on the screen there at the bottom, that's how we get them nice and neatly. 1.95 meters, 3.9, 3.9, 3.9, 3.9, 1.950. Okay, so we kind of got them all neatly laid out there, and obviously that's just maths. That's just that can be applied to lots of other things. Okay, now we need to calculate the S values. Okay, so what are the distance going to be going up the other way? Excuse me, in the building. So remember that the maximum area per sprinkler is 12. Okay, and we've gone 3.9 in the one direction. Okay, so we do 12 divided by 3.9, and that gives us 3.077. Okay, so the absolute maximum you can do is do 4 meters in one way and 3 meters in the other way, and that will give you obviously 3 times 4, 12. Okay, so that's kind of the absolute maximum. But we're only going 3.9 in the one direction, which means we can squeeze it to 3.077 in the other direction. But say that's the maximum. Now we say we've got 15 meters to play with. The maximum we can go is 3.077. So we do 15 divided by 3.077, and we get 4.875, which coincidentally is the same number we had last time. So again, we say, right, we need 5 heads per range going north to south. So now we do the S value. Okay, so we know we've got to have 5 sprinkler heads. So we do 15 divided by 5, which is 3. So the distance to the walls, so S is then 3. Half S is obviously 1.5. So you can see on the screen there, we do 1.5 meters, 3 meters, 3 meters, 3 meters, 3 meters, 1.5 meters. And we end up with 25 sprinkler heads in total. Okay, so we're going 3 meters in one direction, we're going 3.9 in the other. 3 times 3.9 is 11.7. Which is pretty good. As a sprinkler designer, you'd be very happy with that because you're getting as close to 12 as you can. If you're at 12, you might be a little bit nervous because then you're very reliant on the accuracy of the drawings that you've been given, the accuracy of the construction that actually takes place, and the accuracy of the fitters on site to actually put the heads in the right place. Because if you're at 12, then if you're 100 millimeters out, then they're going to be out of rule. So that's no good. So 11.7, very, very happy. But like I said, maybe because of the peculiarities of the room, maybe you can only get 10. That's fine. You just got more heads than you necessarily need. But that there is going to be it's got to be less than 12 anyway, and say you would use as few sprinkler heads as you can. So as I say, you could then do the calculation again the other way around, and you would in this instance, I think you get a very similar result, but you could do it and see how many heads you get that way. So that's an example about how you'd lay it out. And as I say, that is the most basic example, because we've got a nice area to work with, nice large area. We haven't got any other services marked on there. We haven't got any beams on there, any sort of construction bits. So, other considerations, ceiling heights. So again, that there's a maximum sort of ceiling height we can work with. Ceiling construction. Is it open cell, for example? Is it a concrete ceiling? What sort of material are we being using? Are there beams and bays? Are there ducts? Are there obstructions? Void protection, is that required? If so, that doesn't make a difference in terms of the head layout, but it does make a difference in terms of the pipes and the distribution. Coordination with other services. Sidewall sprinkler heads, again, we haven't mentioned, so sidewall heads can also be used. Slope ceilings, again, kind of complicates things somewhat. Alternative wall constructions. So sometimes we want to go less than half spacing to the walls. So if we've got walls that are not the normal construction. And movable walls, which is a good one. So if you've got like a screen that could be pulled across to divide one room into two, so like conference centres, schools, etc., they're going to have this ability to have a wall which kind of is there one minute and is gone the next. That's a challenge for a sprinkler designer, because we need to make the sprinklers work in both scenarios. We need a compliant design when the wall is there, and we need a compliant design when the wall isn't there. So, which it can lead to some kind of interesting challenges. So, say the sprinkler designer, they do earn their money because it's never as easy as that. There's always other things to consider. There's always other services and other obstructions to kind of work around. So say that they do earn their money really. But yeah, that's an appreciation of what goes on when we are laying out sprinkler heads. And as I say, another session, I'll show you another example based on residential, laying out of residential heads. So yeah, thanks for listening to that presentation. Next week, we're going to be looking at sprinkler hazard categories. So that's going to be really tidying up. So I've mentioned sprinkler hazard categories quite a lot over the previous presentations, and I mentioned them again today: light hazard, ordinary hazard, high hazard, category 1, 2, and 3. So it's really a case of tidying that up and going into a bit more detail on each one, giving some examples. So yeah, that's what we're going to be doing next week. Hope you can join me then. But yeah, have a nice rest of the day. And again, if you've got any questions or comments, the email address is on the screen there, sprinklertalk@projectfire.co.uk. All right, thanks so much for listening. Bye.